Alright gang, so our next chapter is chapter 5, Quadratic Functions and Inequalities. Okay, so objectives of this chapter, specifically, graphing quadratic functions once we learn about and know what they are, solving quadratic functions, using graphing and using other mathematical and algebraic methods, performing operations with complex numbers that we'll get out of these kind of functions, and graphing and solving quadratic inequalities, so greater than or equal to, less than or equal to, that kind of stuff. Today's lesson focuses on this one primarily, and this is sections 5.1 and 5.2 in your books, and it talks about graphing quadratic equations and then using graphs to solve quadratic equations. Yeah, you can do it. Alright, so 5.1, graphing quadratic functions. First thing we need to do is know what a quadratic function is. So a quadratic function is defined using the following equation. Y equals ax squared plus bx plus c, where a does not equal 0. Okay, because if a equals 0, then our x squared term equals 0, and we don't have a quadratic. The graph of any quadratic function is going to create a figure that we know as a parabola. So the parabola can either be opening upwards or opening downwards. Okay? Things we can notice about a parabola, they have an axis of symmetry, so they're going to be the same on both sides. Alright? We can describe this one's shape that it's a U, or opening upwards, and we can describe this one's shape as a umbrella, or opening downwards. So as I said earlier, graphing quadratics is one strategy for how to solve them. And here's a really common graphing strategy. So given a quadratic equation, as I said, it's in the form of y, or f of x, equals x squared minus 8x plus 15. Our first strategy we can employ is to create a table of values for x and y. So given this equation, I'm just going to choose values at random, and then use them to put them into the equation and get an output for y. So you want to set up your table like so, the same way as if you were just graphing a line from a given equation. And knowing that our graphs have axis of symmetry, we want to choose a central value and work in both directions from that. As I said, they're going to have mirroring values on either side. So if I usually like to start at 0 and work my way positively and negatively. It's just something I do, it's not something everyone has to do. You can choose to start from wherever you'd like. So 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So given my equation, x squared minus 8x plus 15 equals y, I'm just going to start plugging in points. So take 0. We're going to have 0 minus 8 times 0, or 0 squared minus 8 times 0 plus 15 equals y. So for this one, it would just be 15. Okay, and then go to 1. 1 squared minus 8 times 1 plus 15. 1 squared is 1. Minus 8 times 1 is 8, so negative 7 plus 15, positive 8. And now I'm going to do negative 1, just because that would, to me, seems like a good idea. So negative 1 squared minus 8 times negative 1 plus 15. Negative 1 squared is 1. Minus 8 times negative 1 is positive 8, so that's 9. Plus 15, 24. And I would continue to do this for each of my points. Alright, so if the equation of our quadratic is y equals ax squared plus bx plus c, and we want to be able to solve that for various parts of the equation, we need to know a few things about a quadratic. So we said it's going to make the shape of a parabola, something that's U-shaped up or umbrella-shaped and down. The other thing we also said is that they have this axis of symmetry. So that means if I were to fold it in half, these points would all line up exactly with these points. So, and they are able to be folded over this axis of symmetry. The axis of symmetry comes together at a point we call the vertex. So these are two really important things we need to know if we're going to try graphing a quadratic equation. So these are things we can solve for, given a few pieces of information. So looking at the equation for our quadratic, we can start to use some of these terms to describe our parabola. So let's look at the A term. So for A, if A is greater than 0, we know our parabola will open upwards. And if A is less than 0, in other words, if A is negative, we know our parabola will open downwards. So given A, we can at least start to look at the directionality of our equation. Given B, we can start to solve for the vertex. So the vertex equation of our parabola is B over 2A. And that's going to give us our vertex x value. Okay? So using two pieces of our equation that we're given, we can already find one point in our parabola, that point that's going to start off with our axis of symmetry, as well as the directionality and shape of our graph. So, given an equation, we can employ a graphing strategy. So if given an equation like f of x, or y, equals x squared minus 8x plus 15, we can create a table of values for x and y using this equation. And that will help us to be able to plot those points on a coordinate plane and create our graph. Another piece of information we're given already in our equation is c. And looking at c, c is actually the y-intercept of our graph. And again, the y-intercept is where the graph will cross the y-axis. So x will be 0, and y will be the same as c. Alright, so given an equation, we can employ our graphing strategy of creating a table of values. And the first value we want to look at is our vertex x. So again, the equation for that vertex is negative b over 2a. I'm not sure if I said negative earlier. Negative b over 2a. So using our equation, I'm going to plug those values in. So my b is negative 8. So if it's a negative b, that makes it positive 8. A is 1, so it's going to be 2 times 1. So 8 over 2, that's 4. So I want to start my table of values at my vertex, right? Because that's going to be the middle of my axis of symmetry. Now, I know that it's going to go off in both directions symmetrically. So I can take x values from there and go out from 4 and down from 4. So let's try 5 and 6 and 3 and 2. Okay? So if we plug in our vertex x into our original equation, we're going to get 4 quantity squared minus 8 times 4 plus 15. 4 squared is 16. 16 minus 32 is negative 16. Negative 16 plus 15 is 1. Okay? No, negative 16 plus 15 is negative 1. Awesome. Alright, so we'll go off from here. So then we want to fill in all the rest of our values that we want to find y values for. Now, notice I'm not doing tons and tons of numbers because ultimately, once we start to see the trend for our parabola, we can estimate, we can estimate what the rest of the graph would look like. So let's just fill in some of these. So we have 3 squared is 9. 9 minus 24 is negative 15. Negative 15 plus 15, 0. 2 squared is 4. 4 minus 16, negative 12. Negative 12 plus 15, 3. 5 squared, 25. Minus 40, that's negative 15. Plus 15, 0. That makes sense. We're creating that axis symmetry. I'm going to cheat because I know the rule. This is going to be 3. Okay. So now that I have these table of values for my x and my y, I can transfer them to a coordinate plane. So a rough sketch of my coordinate plane. It's not going to be totally to scale, which is okay. We're just free drawing it on the board. So my vertex is the point I want to start with, and I know it's going to be a 4, negative 1. 1, 2, 3, 4, negative 1. Then I can plot my next point, 5, 0. Plot my next point, 6, 3. And then back, so 3, 0. And 2, 3. And then we just connect the dots. Okay, and now I have a solved graphed quadratic equation.